Okay. Yes. So we will start off with this session. As I mentioned, we will look at the fundamentals of networking. These are the different topics we will try to cover in brief. Obviously, 1 hour is not enough for learning all the sessions, but even if we learn something and we try to connect some dots, my whole and sole aim for doing these free workshops would be done. So that's what I'm aiming for. So we will start off with understanding what is a VPC, inside VPC what is a subnet, route tables, internet gateway, NAT gateway, concepts like security groups, NACL, VPC endpoint. And mind you, these are not very difficult concepts to learn. Sometimes we just get too much confused in basically information overdose happens, right? So if the approach is good and we stick to core concepts, then I think we can learn it fast, and that's what we'll try to do. Okay, so moving on. So why VPC exists? By the way, VPC is nothing but virtual private cloud. Okay. So earlier you used to have, before cloud existed, like AWS, GCP, which is the Google Cloud Platform, and Azure from Microsoft. Before these technologies came in, you used to have physical network, physical firewalls, everything was there. But with cloud, you had something known as a virtual private network. Okay, and VPC is nothing but a small virtual network inside of your entire AWS ecosystem. That's what VPC is about. Okay, and think of it as a private data center in AWS. Okay, and as I have mentioned, it could be an isolated network. It will have some IP ranges and some subnets. We will talk about what subnet means. Bear with me for a while. And it generally has a list of IP addresses assigned to it, with the help of CIDR, which is nothing but a way in which you can assign IP addresses to a VPC, or to any such thing which requires IP addresses. So when I say 10.30/16, it basically means that this VPC can contain addresses from 10.00 to 10.02 255.255. So basically it means that this VPC can have approximately 65,536 IP addresses. Okay, so /16, when means 16 bits. The last two octets can vary from 0 to 255. That would comprise the 65,000 IP addresses. By the way, don't confuse, or if you don't understand this IP related thing, don't get bogged down. It is for people who know a bit of AWS. I'm trying to cover everybody who know things in AWS and in technology, and somebody who doesn't know anything. Okay, so in between it may just go above your head. Don't worry about that. Try to see what you can learn. Okay, don't think that don't get discouraged in between. So if you don't understand the IP related part, forget about it. Okay, that is not that important, I would tell you. Okay, now understanding little bit in a diagram, this would help. So what happens is, so you have internet outside and then you have a VPC inside of your AWS. Okay, this VPC can contain either a private subnet or a public subnet. As you see, public subnet would have a connection to internet gateway. Internet gateway is one kind of a gateway which is actually connected to the internet. So if you have to go out from your AWS, you have to go via internet gateway. As simple as that. Okay, and public subnet means nothing but, we will anyway cover these topics. Public subnet means nothing but it would have route to internet gateway, and it would have at least one resource having a public IP. Simple. Okay, private subnet would not have these two things. That is why it is private. Generally for real world applications, your EC2 where your code runs would not be in public subnet, because you don't want internet to directly access your servers or your databases, so you keep them in your private subnet. Okay, but your your servers like load balancers, which obviously when you're making a call from outside from a browser, the first thing which it calls would be the ALB or the application load balancer. Generally that remains in your public subnet. Okay, EC2 can also remain in a public subnet, but that is not advisable. Okay, why this keeps on happening. One second, it gets stuck. I don't know. Okay, as I mentioned, we will cover all the topics one by one. So we little bit talked about VPC. VPC contains these two kind of subnets. Each subnet can have its own resources. Okay, a private subnet generally contains a EC2, or it can have anything and everything, like database, DynamoDB, RDS database, anything could be there in that. And public subnet, obviously how it differs from private subnet is that it is connected to internet gateway, which in turn is connected to your outside world, which is the internet. Okay, now coming to subnets. Subnet is nothing but a slice of VPC. As we saw, VPC contain multiple subnets, so subnet becomes a subset of VPC. It is usually mapped to one availability zone, which means each region. So let's say you have in US you have your US East region. Okay, each such region will have multiple availability zones, and these zones are created so for fault tolerance, so that if one zone is failing, there is another zone to go back to. Okay, in that region, it's not that everything in that region goes down. So that's why you have multiple availability zones in a region. Okay, and usually it is mapped to one region. So we saw VPC with /16 as the CIDR. Subnet would be little bit /24. With /24 means that the overall IP addresses available to subnet would be lesser. Okay, so because it means that the number of digits which are variable becomes less. Okay, and the number of digits which are fixed is 24. There it was 16. So when the number of digits which can be changed or varied becomes less, so you will have less range available for you, which is 256 in this case. Okay, that's the idea. And obviously the benefits are you are able to segment internally in a VPC different subnets you can have, right? And security and availability, these are the major. Okay, coming to the two subnets inside a subnet. So you can have either a private subnet or a public subnet. We little bit talked about the two in the first diagram which we saw, the VPC diagram. So what happens is, from internet you would have an internet gateway, which we just saw in the diagram, and then internet gateway can lead you to a private subnet or a public subnet. As we saw, both the connections are possible. When does a subnet become public? When it has route to internet gateway and one of the resources has IP has a public IP address. That's what we saw. And when does a private subnet becomes private? By default it is private only, no need to make it private. Okay, everything is private. If explicitly you are not making it public, it becomes it's a private subnet. Okay, it doesn't initially or by default it will not have any route to internet gateway or direct access to internet. And examples I already mentioned. Load balancer generally would sit in public subnet because it is nearer to the internet. That is the first point of contact when a call is made from browser to your application. So ALB comes first, then ALB to the actual EC2s where your application is hosted, or your Lambda or Fargate, whatever is your compute engine, that would generally sit inside a private subnet, as we mentioned. And obviously the database, you don't want to expose your application and your database into a public subnet. Generally that remains in a private subnet. Okay, CIDR, quickly we'll look at the definition. It is classless inter-domain routing. Don't worry about the big full form. It is nothing but it provides you a method to give you a range of IP addresses. As we saw for a VPC, we saw a range of 65,000 IPs, with /16, and for a slice in that VPC, we saw you can have lesser than that range. So maybe /24 would lead you to around 256 IPs for that subnet. So here same thing I have mentioned, that /16 provides those many IP ranges, /24 provides lesser, 256. Smaller subnet mask becomes more IPs, simple, we have already seen. And larger subnet mask 24 would give you fewer IPs, because 24 means that 24 digits are fixed, or 24 digits are fixed, you can think of it in that way. And 16 means 16 digits are fixed from that IP, and the others are variable. So that is why 16 gives you more. Okay, moving towards internet gateway. Before this, okay, there are few people. Oh, I don't know, I should have made it. Okay, anybody, let me just check if there is any chat. What is Passion Host? We will come to that, Kiran, don't worry about that. Internet gateway. Internet gateway is nothing but a door between your VPC and internet. Okay, I already spoke about that just a while back, and it is attached generally to VPC, not a subnet. Okay, and remember, when we talk about internet gateway, it means it is available or enables two-way communication, inbound or outbound. So without internet gateway, there is no incoming or outgoing. So you require internet gateway to make connection with internet, and internet to make connection with your application. Both the things become possible because of internet gateway. That's how important it becomes. And key points are, it is attached to VPC, not subnet. Something to remember. And generally it is highly available, and it's a managed AWS service. Public subnet obviously requires a route to internet gateway, and one resource IP has to be public. We already talked about that. Okay, so internet gateway enables two-way communication. Just remember this one point. That's it. Okay, NAT gateway. NAT gateway, how it is different from internet gateways, provides a one-way secure exit. So when, let's say, as an application, you want to download some updates, or call some APIs which are outside your company or outside your VPC, and you want to make a call. So you are going from your application to internet. At that point in time, you would require something known as a NAT gateway, because you want a one-way exit. You don't want internet to reach you, but you want to reach internet. Okay, so NAT gateway, remember, is one way from inside to outside, outbound. Internet gateway is used for both inbound and outbound. Okay, and it is closer to the internet. NAT gateway is more inside the VPC. NAT gateway generally to go out, so your resource from private subnet would connect to NAT gateway to internet gateway, and then internet gateway anyway has connection to internet. Okay, so that's how the flow works. Okay, route table. Now route table is actually nothing but it basically internally it's a mechanism to for AWS to know where it has to route traffic for it to reach that destination. Okay, so like a GPS. Let's say if you are going from if you're going to from if I'm in Bangalore and I'm going to, let's say, something which generally you go by car or bus, let's say it's Mysore, and if I have to go from Bangalore to Delhi, then obviously I have to take highway for going to Mysore. Okay, so that's how that is the route which we need to take. And if I have to, if the destination is Delhi, then it's not the highway, it is the airport, correct? So you have to go to the airport, and then from airport to flight, or to railway station, from railway station to generally, I mean, you can always go to Delhi by car, I'm not telling that, but generally speaking. So just to give you an example, that's how it happens. So route tables helps you based on the destination which IP address to pick. If trying as it is mentioned here, if traffic is going to destination X, how can you reach to X is what it will basically help you in doing. Just a second, there is some, okay, just give me one moment. I don't know. Okay, so we talked about route table. These are the key features. I don't want to go into each and every feature right now, but you got the point that it is like a GPS for network traffic. Okay. Okay, this is very important because a lot of times people get confused as to how the subnet can become public. As I have mentioned multiple times, what makes a subnet public is when it has a route table, when the route table in a public subnet points to internet gateway and at least one resource has a public IP attached to it. Okay. Smaller, simple point, but important point. That's why I wanted to cover that. Okay, NAT gateway flow. Now we will go a little bit deeper into each of these gateways we talked about. So we talked about internet gateway, inbound, outbound, NAT gateway, which is generally outbound. Okay, it takes if your private subnet resource like a EC2 wants to connect to any API outside, then it generally takes the NAT gateway route. Okay, so we will go a little bit deeper into these gateways and see what is going on. So EC2 to private subnet to NAT gateway, and then NAT gateway generally sits in the public subnet only, as we saw in that diagram of VPC which I showed. Okay, so public subnet to internet, that's the flow which happens. And why you have NAT gateway is because somebody wants to reach internet from outside. Okay, that's why NAT gateway concept came into picture. Okay, and not for internet to initiate connections. Okay, NAT gateway won't help you if you want to connect from outside to the application inside, or to the private subnet inside where the application is hosted. Okay, little bit on security groups, because these are all important topics. Simple topic, it's nothing much. It is nothing but a bodyguard of an instance. So you have different instances like EC2 instances, which would be there in multiple EC2 instances could be there in a subnet, right? And what generally happens is you would need to have a firewall attached to these instances, to basically have permissions, what is allowed, what is not allowed, correct? And generally you call it stateful, because if inbound you're allowing, then automatically the response or outbound gets allowed. Okay, so you call it stateful in that way, and it supports only allows. So there are two concepts like allows and denies. Security groups generally supports allows. So just think that it is like a bodyguard of a EC2 instance or any compute resource inside of your subnet. You attach that security group to it, which will have the permissions and different policies for that instance. Okay, So user to security group. So if somebody is trying to reach EC2 and you have to access something from EC2 like that application, that security group attached to the EC2 should allow that. Okay. And generally you do comparison between security groups and NACL. NACL is nothing but network access control list, and it is attached to a subnet. Okay, here it was attached to an instance. This NACL gets attached to a subnet and it applies to all the instances in a subnet. So it's a subnet level permission control mechanism, and security group is a instance level permission mechanism. Okay. And it is stateless. That was stateful. Here if inbound is allowed doesn't mean outbound is automatically allowed. It supports both allow and deny. Okay, internally. That's the basic thing about NACL. Now let's talk about how the traffic flows. I'm sorry about the flickering, which you may be seeing in my background. Somehow the light is flickering. I don't know, but yeah, I mean, we'll continue. So there could be two scenarios where VPC. Now if you have seen the diagram which I showed, VPC internally has an internet gateway, correct? So why can't just EC2 directly use it to connect to the internet when EC2 could be public, is what we are trying to discuss. So how EC2 can be public is when EC2 will have public IP associated to it, and it would reside in the public subnet and not in the private subnet. As I mentioned, EC2 can reside anywhere. Okay, it's not a white and black case that it should reside only in private. It can be there in public, and then from public subnet to internet gateway you can have a route, and internet gateway anyway gets connected to internet, right? So EC2 can have both public and private IPs, and when, let's say, when it is trying to call google.com and it has a public IP, Google understands that IP and it gives the response back, and that's how the response would directly go back to EC2. Here there is no gateway we required because EC2 already was in public subnet, right? Why you require a NAT gateway additionally? But does it happen generally? It doesn't happen generally that you will have EC2 sitting in a public subnet. Okay, this is just a hypothesis which we are trying to evaluate. If this happens, then what? Then do we require NAT gateway? So we don't require NAT gateway in this scenario. Okay, and the second case could be where EC2 is inside private subnet, which means it is private. Then for it to go towards internet or to reach out to internet for any API call or whatever, to download any updates, so obviously Google won't respond because it's in private subnet and there is no public IP available to which it will respond. Okay, so why are we not giving EC2 a public IP, generally speaking, the real world scenarios? Because if internet to EC2 it becomes reachable, then all your servers, your databases, internal services, they are reachable from internet. Okay, which is usually undesirable. You don't want to expose your core application and the data which is residing to be in the public subnet, so that internet becomes reachable easily, right? So generally that is why EC2 is kept in private subnet, as I already mentioned. So that's why you have NAT gateway coming into picture, because that allows you to have so NAT gateway acts as a bridge between EC2 being in private subnet, NAT gateway being in public subnet, and NAT gateway then connecting to internet gateway to finally connect to internet. That's the general flow which happens, real world scenario. Okay, and it prevents internet initiated connections because NAT gateway doesn't allow that. It's just for outbound. Okay, This is simply, you know, basically going through the IPs. I already mentioned how it happens, you know, so we don't have to go through it again. Generally, if you are trying to give a solutions architect or developer exam, you know, if in between I try to, you know, put couple of questions here and there to give you a little bit idea, you know, what they ask. So, and we already, you know, I already mentioned this, that EC2 could be in a private subnet, and if it needs to download any patches from outside, then always think about NAT gateway. Okay, that's the way. If you're going outside, NAT gateway. But if EC2 can be directly reachable from the internet, then forget about NAT gateway. You can, you know, with internet gateway you can reach it, because you know, it's already it would already be in public subnet. Okay, and I mean, you can think of this as this analogy that internet gateway is like a door to internet. Just before the internet you have this door, and NAT gateway is like a receptionist standing before the door, you know, inside the door of the office. So what happens is, generally when a receptionist, you know, employee wants to reach out to, you know, outside world, it can go via the receptionist, but anybody from outside the organization can just like that not walk into the, you know, office, you know. So that's how, you know, NAT gateway refers to receptionist in this case, right? So hope, you know, this helps a little bit understand how is IGW, internet gateway, different from NAT gateway. Okay. Receptionist won't allow strangers to talk to you, but it can allow you to talk to the strangers. Okay, and door is anyway a door. Anybody, you know, door, there is no incoming or outgoing. You can go out, you can come in, right? Okay, and now looking at the other the reverse flow, internet to EC2. If we are going from EC2 to internet we just saw internet to EC2. You know, there are two options again. Internet can directly reach EC2 with the help of EC2 on public IP and being on you know, public subnet with the help of internet gateway. Simple architecture, internet to internet gateway, that is the first point of contact always, then to the public subnet where anyway EC2 is residing, correct? But that doesn't happen generally. Recommended production architecture is, you don't expose EC2 directly to the internet. You would want EC2 be in private, and ALB, generally the application load balancers, they would be in public subnet connected to the internet gateway. So this is how mostly the real world applications generally get architected. So internet to EC2 means EC2 internet has to first reach out to internet gateway, then from there to ALB to your EC2s, which would be residing in the private subnets. Okay, let me quickly check if there are any chats. Okay, does NAT gateway sit inside public subnet and not private subnet? Is my understanding correct? Option that makes as I come. Yeah. Kiran, you are coming from non-tech background. It was a really good question. Okay, so you are absolutely on track. NAT gateway sit inside public subnet. You are right. That's how it is able to you know, reach the internet gateway and finally the internet. Okay, it has to sit in the public subnet, otherwise, you know, what it is designed for will never happen. Okay, VPC endpoint. Now hope you know, internet and NAT gateway are little clear now. Subnet, VPC, route tables, little bit of an understanding we got. Okay, so majorly we saw NAT and internet gateway and subnets and NACL and security groups. These 4 or 5 things we discussed, and I think NAT and internet gateway I tried to mention at least 5 to 6 times, so everybody, you know, should have should know the difference between the two by now. Okay, even if you are from non-tech background. Kiran also got it, so somebody from tech background definitely should have got it. So VPC endpoint. Now what is VPC endpoint? Now think about a scenario. We already saw this architecture where EC2 to NAT gateway to internet gateway, and then finally to internet. This is what generally happens if from EC2 you want to move to internet, okay, because EC2 generally would be in a private subnet. Now if say EC2 wants to call an AWS managed service like S3, that can happen, right? It keeps on happening day in day out. So EC2 making a call to S3 or DynamoDB, one way is going with the NAT internet gateway, because S3 and these databases, assuming or generally they don't reside in the private VPC cloud, okay, so they are not in that VPC. So if you are trying to access them, what would you do? That's the question. So one way is to go via the route which we are talking about from the last 15 minutes, which is NAT to internet to NAT to internet gateway to internet, and then from internet you access S3 like everybody is doing. But instead of doing that, there is another way which AWS provides, which is known as VPC endpoint. So what does VPC endpoint do? It allows your resources in your VPC to access AWS services without going to internet, without going out to internet. Internally only via a mechanism known as VPC endpoint, you can reach out to the other services which are not there in the VPC cloud. And you can reach out to various services like S3, DynamoDB, SQS, SNS, etc. Okay, and traffic advantage is traffic doesn't go to internet, traffic doesn't go outside, and obviously it is faster and cheaper. It's a mechanism created by AWS to enable this thing that any service, if it is getting called from a VPC and the other service not residing in a VPC, what would you do? You don't want to go via this this route, because this is this leads to, obviously latency would be higher when you're going via NAT, via internet gateway. You reach internet and then you call like others are calling S3 or DynamoDB. That's not an ideal way of doing it. So AWS wanted a mechanism so that internally you could connect to these services which are not available in your VPC. That's why it came up with this, and it's faster because you are not going out, and it's cheaper as well. Okay, so creating a NAT and internet gateway, all these things require costs, AWS costs. So remember that thing as well. Okay, now I think we already spoke about it, but quickly, VPC endpoint versus NAT gateway. If it's a service to service inside same VPC, let's say in that same VPC you have EC2 to RDS or ECS to ALB, you are going, all of them are in the same virtual private cloud, then you don't need any VPC endpoint. You can just directly route or access that service, provided the policies allow. Okay, so you don't need any VPC routing or any VPC endpoint. This I am talking about when inside the same VPC you have the two services available, which can very well happen. You have multiple services which can sit in the VPC. So this is not a problem. You directly connect. The traffic never leaves the VPC only. Forget about going to internet, right? This is normal private networking. Second thing is service in VPC, but going to the control or wanting access to a AWS managed service like S3, DynamoDB. What can be done? As I mentioned, there are two options. One is the first option which we mentioned, which will be higher cost, higher latency, less secure. And the second option, we already mentioned why VPC endpoint came into picture: more secure, less cost, and low latency. Okay, so services like S3, DynamoDB, which live outside your VPC but inside AWS's public network, you should always use a VPC endpoint to access them. Okay, this is the major concept when you talk about networking in AWS. And VPC endpoint, it gives you a private route. There is no NAT involved, there is no internet involved. Okay, all those things add to the complication. those things are not there in VPC too. So if this is what you want to do, go for a VPC endpoint. Okay, now it's the same thing. I think I have already couple of times I have mentioned how traffic looks like, but it will make it clear if you are on the edge. So this VPC can contain both private and public subnet, as we mentioned, and inside your private subnet you can have a VPC endpoint, which is basically helping you directly call S3 instead of going via NAT gateway and internet and then internet calling S3. Okay, so there are two routes which you see, correct? The second one, which involves the VPC endpoint, is the ideal route if something in the private subnet wants to reach a service which is not there in the VPC. That's what I was trying to mention all the while, right? Yeah, hope it is clear. Okay, moving on. And then let's say if there is the third case where service is there in VPC and it has to reach out to a service which does not support VPC endpoints. Now if let's say we are able to use VPC endpoint, it doesn't mean that all services have that flexibility. Not all services right now support VPC endpoints in AWS. For example, email. So then if that service doesn't support VPC endpoint concept, then you have to go with that route only, which is NAT gateway to internet gateway to internet to SES. That's the idea. So it also, those services like S3, DynamoDB, they support VPC endpoint, SQS, SNS, all those services, they support VPC endpoint. So you need not worry about those services. But if it is something which doesn't support, like email service, then you have to go with that route only. Okay, coming back, this would be the last concept, then we will wind up. Gateway endpoint. Now there are two types of VPC endpoints, generally speaking. One is the gateway endpoint, other one is the interface endpoint. Very important concepts as far as certification is concerned. Okay, AWS really likes asking about these two endpoints from time to time. It's a very simple concept, but people obviously get confused. So gateway endpoint is basically supported by these two services only, which is S3 and DynamoDB. That's it. And if you have to reach to S3 from EC2, then use a gateway endpoint. You would have to use a gateway endpoint. Generally, internally, gateway endpoint and interface endpoints, they architecturally, they are a little bit designed differently. Okay, so generally gateway endpoint will talk about route tables. Okay, there is no ENI created, no private IP created with respect to gateway endpoint. So these couple of points you would need to remember. Okay, so if you are talking about S3 and DynamoDB getting accessed from, let's say, Lambda, EC2 or any other compute service, then think about gateway endpoint. Okay, and if it is any other supported service like Secrets Manager, SQS, SNS, all the other services which support VPC endpoint, then you go for an interface endpoint. Interface endpoint is different from gateway endpoint in the sense that it has something called as a elastic network interface. The way it is architected. Okay, so if in the exam there is a question which talks about elastic network interface, then it is referring to the interface endpoint only. Okay, we will not go into detail on ENI and all right now. So that's how the interface endpoint is different from a gateway endpoint. And frankly speaking, it is not private versus public. It is more generally, people get confused with gateway endpoint and interface endpoint. By the way, don't get confused between internet gateway and gateway endpoint. They are totally different concepts. Okay, gateway and internet gateway we already discussed, that is done and dusted. Internet gateway versus NAT gateway, that's what you need to know, what is the difference. And inside of VPC endpoint, you have then two types, gateway endpoint and interface endpoint. That's it. You need to know the difference between these two, how they are different and what are the services which are using interface or gateway endpoint and vice etc. Right, that's the idea. So both are private only. It's not that gateway is public. The only real difference is, as I mentioned, gateway endpoint never talks about route table, never talks about ENI. It's more on the route table entry, and it's only supported by S3 and DynamoDB. Interface endpoint, you would have something like creation of ENIs and hourly endpoint cost. There are some features which you would need to know, some differences, but ultimately, remember ENI if you think about interface endpoint. Okay, and just to quickly look through a diagram, basically, if it's a route table based, then it's generally would be a gateway endpoint, and S3 and DynamoDB are the two services you would access. If it is interface endpoint, then it would be ENI based, as we discussed, and you have all the different services we talked about, which could be secrets manager, SQS, SNS, different various services. Okay, only thing is gateway endpoint is supported by S3 and DynamoDB majorly. Okay, this would end the session. Hope it was informative, and if there are any questions, I'll be happy to take those questions now. Let me quickly go to, sorry, stop sharing. Okay, so hope we covered. So let me also quickly recap what we covered. I didn't want to too much go into depth of each and everything. Basically 3 concepts we covered. Hope that made sense to all of you, tech or non-tech. This is just a small feedback sheet. It would help me, and little bit change if required. It would be great if you could fill that out for me, just to get a some kind of feedback. And there is also a community which we are trying to run, especially for AWS, people who work with AWS. So if you would like to be a part of that, you can tick that box in this form. I mean, there is no charges and all. It's just would be a community of like-minded people wanting to learn in AWS, and obviously if there are any opportunities arise, we can try to look into that group and take it from there. My only question is, can we get access to recording, because it's so yeah, that's I would see, and see, it's not the last time I'm doing this session. I'll be doing a series. Okay, so next session is, and I'll be repeating these sessions. Okay, so I'll see if I'm already there in YouTube also. I'm talking about these concepts on YouTube, and the company where which we have a consulting company ourselves. It's known as Epicenter AI. So on that channel, I talk about these concepts anyway, and I'll be doing a series. Next session would be on compute services. We will talk about the different compute services which are there in AWS, simple concepts related and to that. The way I do it is that we see the major features in that service, what is the best use case for that service, and what is not the ideal use case for that service. Okay, that's what confuses most of the people. So that's how I've tried to architect that presentation, and generally that's how I have done it in my videos as well. Thanks for that, Kiran. But I'll see if we can share the recording. If I push it on YouTube, I have to decide on that based on the future sessions. Then obviously it will be available publicly, but it will take some time. Till that time, bear with me, and you can always I'll be repeating. It's not the last time we are doing a networking session. We will do more sessions, but maybe little later, after a month. The next would be, all these sessions would be in sequence, so that somebody who is trying to attend all gets a heck of all the concepts in AWS. Okay, So we started out with IEM. This is the second one, which is in networking. Third one would be on compute services, and then other sessions we'll try to do. Okay, I'll reach out to you. Okay, YouTube channel. Okay, let me look at that. Let me check if I have the. Sure, I can send that. Sure. Yeah. Hopefully everybody has filled that form. That would help me understand if you're interested, and if for any future workshops you want to get any updates, and we try to do any QA and all. So this will all continue. Okay. First, right now the roadmap is to have all the sessions, so that we can cover the major concepts. And we take it from there. Okay. With that said, I'll take your leave, and please provide your feedback. Hopefully it was good. I've tried to keep it as simple as possible. Making it simple requires a lot of effort. So I can keep on doing a lot of tech jargon, but that's not the point, because concepts are only 3 to 4. Okay, if these are the 3 to 4 concepts in networking. Now if you know what we discussed today, you are done with networking. You are good to go. Okay, I'm telling you. Okay, you don't have to learn everything for you to get started. That's the myth which people have. So you need to know only that 20% which gets you started. So that is the 20% I'm trying to teach in my tutorials. And once you have that 20%, then you can at least get started, complete couple of workflows, understand the different services, or how generally the overall AWS ecosystem works. So it gives you confidence, and then you can little bit go into the depth of each of them, right? Okay, thanks everyone. I'll see you in the next video. Till that time, this is Romit signing off. Bye. Cheers.